do this. Okay, so when we have this example, Lake Travis will rise 2 feet as it rains. What happens first? Does it rain or does the water rise?
It rains.
It rains. Okay, that makes sense. So in this case, rain is your independent. The rising of the water in the lake is your dependent. So if we were going to write a statement on that, we would say that the water, how much the water rises depends on
How much it rains.
how much it rains. Okay, so we have our independent and our dependent. Some cases there's not a cause and effect relationship. There may be a correlation, but not necessarily this has to happen first. That's an example like this one, okay? We won't see a whole lot of these, but in this case it doesn't matter if you measure the arm span first or the height first. So you do have a few of those situations that really could go either way. The majority of our situations are going to be really clear that this is going to be dependent and the rain is going to be independent. Okay, so this would be independent for rain, dependent for the amount that it rises. What we're going to see most often is going to be like number 3, where we have an equation. In this case, y equals 2x minus 1. We have these 3 names, so to speak, that will be independent. So we have x is independent, domain, input, range is output, dependent, y. If I have, for example, I'm using that, if x is 0, what is y? 2 times 0 minus 1 is
1.
negative 1. Remember, if you have x as something, you're putting it into that equation, that function. What if x is 2? What are we going to get? 3. Make it harder. What if it's negative 5?
I have these. It's gonna be negative 2.
Negative 11.
Negative 11. So negative 10 minus 1. So, you have, in this instant, you have input and output where you're putting some kind of value in for x, and you're getting a result that's y. So in this case, what I'm fixing to write, the value of y depends on the value of x.
Get back to school.
So the variable for x, these names that are up here, the variable for x is called the input or independent. Is what happens first. And all of those values are domain. On the other hand, y is your output or your dependent, and all of those values are your range. Here she can see it. You need to know the vocabulary. All the things that mean domain, x, input, independent, range, output, dependent, y. All of these come first. All of these come second. It's like they do in a chart table like what we've done before. So let's summarize this. If we have the one about the lake, it's going to ask you about independent, quantity, or variable. That means the words. So here, this is going to be for independent. What comes first? Rain. Whatever comes first is your independent. And you have to say them sometimes for it to make sense. The water rising is your dependent. And so if we're going to write this statement down here at the bottom, underneath this, let's write this statement. The amount the lake rises depends, you've got to have that word, you can't just make up your own, depends on the amount of rain. The amount that the lake rises depends on the amount of rain. Value means exactly that. If you have a value, this is a number. So for this particular example, we're talking about domain of 15 inches rising 2 feet. If we have the arm span on the second example, those could be interswitched. It doesn't matter which one comes first. So here, we're just going to put either. Don't have that many of these situations, but occasionally you may have a question about which one comes first. If it specifically asks for a domain for independent or dependent, it should be clear. Then we have our function here, like we did at the top. We filled that in. Which one came first, X or Y? X. And you can always look at your table if you need to know that. In our equation, whatever this is, in the problem, whatever letter, is going to be your independent. Whatever is equal to your result is going to be your Y. So in this case, if we have an example using that function, we said that if X was 2, and we put it in that equation, what's 2 times 2 plus 1? 5. So if X is 2, then Y is 5. So when we label it, we want to say, first column is X, comes first. Second column is Y. Whatever the second column is, our balance depends on how many years that count has been there. And we think about it every time. On number 2, sometimes we have some long situations. Garrett is in charge of making 120 corsages for homecoming. He decides to ask classmates for help. The number of corsages each person can make is represented by this function. First of all, remember this. Whatever is our result, we talked about function notation, that's your Y. So if I wanted to keep everything in X and Y, this one has to be our X. So when this says, what is the dependent quantity? Think about them in terms of your XY chart. What's going to come first? Is he going to get people to help, or is he going to make them? He's going to get people to help. So this is going to be our help, or our classmates. This is going to be the number of corsages that they can make. So which one is dependent? The corsages. So the dependent is the number that they make. And we can fill in our table according to this. This is how many that each person makes. If he doesn't get any help at all, well, 0 plus 1 is 1. 1 goes into 120, 120 times. He's going to make them all by himself. If he has 5 people that help, what's 5 plus 1? How many times is 6 going to 120? 20.
Oh, yeah.
So that means that each person only has to make 20. If he gets 12 people to help him, or 11 people to help him, which makes 12, 12 goes into 120, 10, so they only each have to make 10. So the more people that help, the fewer each person has to make. So the number that each has to make depends on how many people are helping. So we're going to look at some of the rest of these and determine what is our independent and our dependent. Do you give the rest of the answers to the front page? This is the food segment. Miles that can be driven depends on the amount of gas that's in the tank.